This is Debbie Hill, and this is another skill for the IV workshop. You've got to learn to read an arterial blood gas report, or ABG. Remember, the lab doesn't draw these, respiratory draws these. This is the best way to know for sure the status of your patient's carbon dioxide and oxygen level, and if things are off so bad they've been thrown into acidosis or alkalosis. Everything has a pH. We even get the soil tested on the farm for its pH. The body's pH is normally 7.35 to 7.45. You have to learn that. A pH below 7.35 is acidosis. So you're going to determine if the patient's in acidosis or alkalosis by looking at the pH. If the pH is above 7.45, they're in alkalosis. That's the first thing you look at. Then the bicarb level, bicarbonate level, normal is 22 to 26. This is your what we call metabolic component, and it's controlled by the kidneys. Your CO2 level, which we breathe out CO2, is 35 to 45. This is controlled by the lungs, so we call it respiratory. All right. And these three norms you need to know. Do you notice in reading an arterial blood gas, we don't even look at the oxygen content? You get that on the report, but it's not significant in determining their acid-base imbalance. Now I have a little acronym to help you learn it. It's the word Rome, like the city of Rome. And you can draw a little line here if it helps you. Respiratory, R stands for respiratory, opposite, and you'll understand that in a minute. That's talking about the way the arrows go. Respiratory again is the lungs. It's your CO2 level. Metabolic, equal, and that means the arrows are going the same direction. This is controlled by the kidneys, and it's your bicarb level. Okay? Now hold that thought. And let's look at an arterial blood gas report, and then you'll understand it. All right, first, this is the report that came back from the lab, okay, from respiratory therapy. The pH is 7.2. If you look at your normal values, this pH is low, the arrow goes down. And draw your arrows. I still to this day draw my arrows, okay? So if it's below 7.35, the patient is in acidosis. Now, we don't know yet if it's respiratory acidosis or metabolic acidosis. So now we have to look and see where our arrows match up. Well, the bicarb level on the blood report is normal, so it's not that. But the CO2 level is elevated, it's 55. Our arrows are going opposite. The pH is going down, but the respiratory component, the CO2, is going up. Respiratory is opposite. So this is respiratory acidosis. Again, it's acidosis because the pH is going down. CO2 is actually an acid. A good example of this is your COPD patient. They retain CO2 and they are in a constant state of respiratory acidosis. Their pH is low. Their CO2 level is elevated. Respiratory acidosis, your arrows are opposite. Our second example for respiratory, look at our pH at 7.55. Anything above 7.45 is alkalosis. So this is alkalosis, all right? But we don't know if it's coming from the kidneys or the lungs, if it's respiratory or metabolic. So let's look at the bicarb component. On this patient, it was normal. Our CO2 level is low. It's below 35 to 45. It's low. So now our arrows are going opposite, right? Respiratory opposite, so it's respiratory alkalosis. All right, that's an example of respiratory acidosis and an example of respiratory alkalosis. Those values can change. But look at your arrows. They're always opposite. Now let's look at another example. Here's our pH at 7.35. That's acidosis again. It's less than, our pH is 7.32. It's less than 7.35. That's acidosis. But we don't know if it's metabolic or respiratory. Look at your bicarb component. Normal bicarb is 22 to 26. So this is low. My eras are equal, aren't they? And then my CO2 component is normal. My eras are equal, so it's metabolic acidosis. You understand that? So go back to our word, respiratory opposite, metabolic equal. Metabolic equal, my eras are going the same way. So it has to be metabolic acidosis, not respiratory. Now let's look at our final problem. Our pH is 7.58. It's above 7.45, so it's alkalosis. But is it respiratory alkalosis or metabolic? So we have to look at our other two components. It's like a puzzle that you work out. Our bicarb level, normal is 22 to 26, so this is elevated. Our CO2 is normal. Metabolic equal. Our arrows are going the same way. It's involving the bicarb component, okay? So bicarb is your metabolic, so it's metabolic alkalosis. Again, an example of metabolic acidosis, metabolic alkalosis, respiratory alkalosis, and respiratory acidosis. In your IV syllabus, you have a handout with 10 to 15 real patient blood gases that you need to work. Okay, just start with your pH and then determine if your arrows are opposite or equal to determine if it's respiratory or metabolic. And we'll go over these answers in class. Thank you.